No, not based
Yeah.
on magnetic declination, because that actually comes from just the fact it doesn't match the globe and where the symmetry should be. And there's no real
Yeah.
true way to verify declination. In the north, say you have Polaris, and then you know that you have your geographic north, and then you can actually
Hmm.
look at your compass and you can measure the difference in the degrees between the magnetic and geographic north. You don't have that in the south, right? So yeah.
True that. True that. True that. And I was referring uh, to a layout of the flat Earth model, instead of globe, because yeah,
Yeah, I've
globe
seen the
should be
magnetic
symmetric.
declination laid out on that. What I'm saying is that that data is heavily in question for me when it comes to the South, because it's just what they say. The way they got that data was they kept on crashing and dying, assuming a globe, and they kept on not being symmetrical. And it took them decades and billions of today's dollars to eventually map out a declination map based on where they needed to go to actually get where they're trying to go, as opposed to what the globe predicts. And that's how they made that map. So
Hey, g'day.
Well, it does flow, right? It does change though, like a little bits, kind of like a oscillation in a way. Am I correct on that or no?
what do you mean? What changes a bit?
Uh, the um the positioning of or the degrees, like how powerful it is, I guess you would say. Like if it was 179, then 5 years later it was like 175, then kind of back. Is there a studies that deep into it, or?
So again, like I all of the claims of the declination in the South are just heavily in question. But like in the North, yes, in the North, magnetic declination changes slightly. So there's a few different theories as to why that happens. But in the South, I don't know. I'll
Gotcha.
tell you one thing, that we were in Punta Arenas. We flew towards Antarctica, and I had three different types of compasses, including a floating compass, military grade compass. They all read south or almost directly south the entire flight.
Oh wow.
G'day. Can I say a few things at all, please?
Yeah. Thank you, man.
No.
Yeah,
Thank you, Butts.
yeah. Thanks for letting me talk. So you probably can hear from my accent. I'm actually from Australia. Before I go on with actually talking about declination, I did want to say that, Whitson, I do believe you when you were saying that, your intent was not to do any vapes in front of the camera. I think it's a little bit of a nothing burger, so I hope everyone just moves on from that. In terms of declination for the South, while you might not be able to trust, like, say, a compass and all that sort of stuff, right? If you just if you locate where a sunrise happens, and then when you locate where a sunset happens, you can just halve the distance or the angle between those two locations, because your halfway point between a sunset and a sunrise is the meridian point, and that'll be your north, and the opposite will be your south, and that's basically it. So that's how you identify what's north and south. And I mean, you saw it with McToon figuring out where his north and south was, and that's then you look at your compass. If it's 5 degrees out from that south strike, then you know your declination is 5 degrees out. That's it.
Well, okay. How do you know what direction that the sunrise or sunset is?
Well, if you've got something where you can, if you can point, like let's say you got a telescope on it and it's got a 360 dial on the bottom, right? So you twist it around. You wake up early in the morning. You point it as soon as the sun rises. You go, okay, that's it. Let's say it's 295 degrees or whatever like that. Yeah.
How do you
You
know
wait.
that?
You wait.
How do you know it's
Well, you
295?
point. Yeah, I know that you're going to say that it's apparent, but I mean, you can roughly go,
No,
well,
no,
that
I'm not
one's
even talking about that
290.
far yet, bro. I'm saying, like, you're saying we don't know our cardinal direction at all. We're gonna wake
Yeah,
up
yeah,
and we
yeah.
see the sunrise.
If you ignore your cardinal direction, if you completely ignore it, let's say your baseline is you've randomized, right? You go, okay, so it out of 360 degrees, it rises at this number, and then it sets at that number, and then you go out there and you find out how many degrees there are on the top side and how many degrees on the bottom side, and you just halve it. All right. So if you find that the sun has risen and it's set and it's 180 degrees of difference, you'll just go, okay, we're at 90 degrees from that, we got north. Or if, like what you discovered in Punta Arenas, where where like the distance between where it rose and set was like a 30 or 40 degree difference, well, you've got like 320 degrees of sun arc, and you just divide that by 2, and so you've got, what's that, like 190 or something like that on each side. Rough numbers. I'm
Yeah,
assuming
that's
that.
not
I'm
how it
assuming
works
that's not
though.
right.
Like when, but
Well, it
listen,
is.
man.
It is. That's how you find out where meridian is.
All right, bro.
You've
So,
got 320 degrees.
bro.
Yeah, it's true.
Well, I heard you, and now I'm trying to respond to you.
Okay.
Okay. So sunrise and sunset are not exactly 180 degrees.
Oh yeah,
What
yeah, I
makes you
get that,
think
but
that?
I was just giving rough numbers.
Well, okay, that's my point. If the rises and then the sun sets, and you're going to use this to then determine north and south, you need to know what direction the sun rose and the sun set, and what the difference in degrees was relative to one another, right?
Yeah, but that's why you halve the the two angles.
Hmm.
How is that gonna, dude?
No, it's why you halve the two angles. If you find that the spread of the sun is 270 degrees, right? Let's say it's not 180. Let's say it's 270 degrees. Well, you just divide 270 by half, and then you've got your north meridian line.
I don't know enough about it.
Yeah, consider it. Have a bit of a look into it. You'll find, like, you can go on your timeanddate.com or whatever like that. Pick an angle to the right, pick an angle to the left, find out what it is in half, and you'll get your meridian.
Okay.
Trust me,
In
just
your
look into it.
paradigm, if you assume that the Earth's a globe, then you know that the sun sets up. Then you're going to be able to look over and know relative where the sun's going to set. Like the sun rises, then you're going to know where it sets relative to a globe, and then you're
Yeah,
going to
yeah, but
split that. Okay.
I'm even talking about it from the perspective, like, let's not look at the chart. Let's just have some sort of device which can spin 360 degrees. Let's find out, just put a big ass protractor on the ground, right? And you don't even know where north is. You point one towards the sunrise and the other one towards the sunset, and make fresh numbers. It's perfectly doable.
No, I don't dispute that the method is doable. What I'm trying to explain though is like it requires you assume that we see the sun in an actual position, and you need in your obviously the baseline of your determination is like the relative positions of sunrise and sunset to then deduce north and south from that.
Yeah. Well, I
Okay.
get that. I get that sunrise and sunsets can be a little bit iffy. You could say, well, is the sun truly 1 degree or 2 degrees further around than where it is? We could say that. But if you do it from just a plain sight perspective, the first second you see the sun and the last second you see the sun, if you just use that, it's going to be pretty damn close.
You're saying pretty damn close. What are you
Yeah.
comparing it to know that it's accurate?
Comparing it to the know that's accurate. Well,
Yeah, yeah,
I'm
you
just
said
trying to.
pretty. It's going to be pretty damn close. Like pretty damn close to what?
Well, yeah, within like 1 or 2 degrees.
Of what?
Well, you're computing two angles and trying to find a meridian. I mean,
Okay.
if you use the same theory for sunset and sunrise, if you use the
Mhm.
same, if you go, okay, I'm going to wait for the sun to be exactly half risen on the sunset and sunset, you've got a sort of a rule that you can follow, and you just do the maths.
Okay,
And
I don't know what.
the thing is, from that you get
Okay.
your meridian, and then you can figure out if your compass is 5 degrees out. That's my whole point.
Okay. So
Okay.
you have to assume an actual position of the sunrise and the sunset, and then you're going to use that relative relationship to then try to split and determine north and south based upon that. He said, like, oh, it could be like a degree or two off. Like, dude, I take a light over here on a dome and I move the circle, I move it over to the right. So if I move the sun in like a clockwise circle over top of a dome, right? Depending on how far out it is in that dome, it'll look like it sets off to the left inside the dome, even though it's actually going to the right.
Well, I'm
Because
not. I'm not. I'm not clutching at straws here, trying to figure out like one
crushing
or
at
two different.
straws. What do you like?
Yeah.
Like
Well,
it's
if,
not one or
if,
two
if,
degrees, bro. It's not 1 or 2 degrees. Like, why do you keep saying that? That's what I'm trying to point out to you. It's not 1 or 2 degrees. If the sun is actually going clockwise, just think about that. So
Wouldn't
since
you?
I have a dome, I'm going to take a light that represents the sun, and it's going to move in a circle clockwise.
Wouldn't you
Inside the
wouldn't think?
dome, it'll look like the sun sets over to the left. That's
well,
not
talking
one or
about
two
time is
It's
degrees.
not
complete.
essential. When you guys were in Punta
It's
Arenas, you were
completely
saying
not.
where is the sun going to rise, and you were going. It was something like 2:38 or something like that, and that's those are the numbers you're trying to look for. That's all. But I don't care about domes. I don't care about the accuracy of where the sun is. You get the halfway point. You get the meridian. That's it. That's
All
all
of
I
that
need to
was
say.
based on like the magnetic declination corrections already being applied
Yeah.
relative to the geometric inaccuracy of the globe.
Either way, one of the things you were saying before was how do we even figure it out in the south? Well, that's how we figure it out in the south, just fine.
I'm well aware of the argument about using the sun. I'm pointing out why it doesn't work.
Well, we can do the stars then. We can find if we know a
Okay.
particular star when that star rises on the horizon, then we find the other one when the star sets on the horizon. That can make the accuracy even tighter.
Stars would maybe be better, right?
Well,
We
sure,
don't.
sure.
Okay, but
I'm with
okay,
you.
but again though, like if I project stars into a dome, as I go out towards the edge of that dome, there is optical displacement all over the place for the stars, and they actually flip. So it's like,
Yeah, but I mean, I think it's okay if you allow 1 degree, level of error. I think
I
it's
don't know why
okay.
you just keep arbitrarily throwing out the number one or two. Like it's
Well,
not
because
a real thing. Like you're just
okay,
saying
half
that.
a degree. I don't know, but I
I know
mean,
you don't know, brother. That's what
it's
I'm trying to
not going to
explain
be
to you.
5 or 10 degrees out of whack. That's all I'm trying to say.
All right, brother. Cool. Thank you, man.
Okay. Uh,
Okay.
Thanks.